In this webinar, we're going to have a look at Caddie's mechanical and steel applications. I've drawn the basic base plate on the screen here using some geometry. First, what I'm going to do, I'm just going to click on the polygon, right click, go to Polyline. Let's auto fillet the polyline and let's use the radius of 60. What you'll see, it's actually filleted all the corners automatically for me. Now looking at the symbols at the top left here, the first one you're going to have a look at is the datum symbol. I'll just zoom a bit closer. The datum symbol will fill in the datum character, the datum scale, created as a block for intelligence. You can pick the pen line, the text pen as well. Say OK, and going to the outer side, you pick on it and it'll do the datum symbol normal to the line for you automatically. The same goes for machine tool symbols. Pick on that. Let's use another symbol over here. The pen and line again, text again, the roughness if you want. Create it as a block again. Go, pick on the line on that side and it'll do the machine tool symbol for you as well. It can also do geometry symbols for you. On the top left here, go to geometry. Pick the geometry it needs to be done. Pick a color, pen color for you. Pick it as a block. Say OK. Indicate to the outside and indicate where the symbol must be. And as you can see, it go around, draw the leader arrow, fill in the blocks and fill in the physical information for you. Also that you can do is tolerancing and automatic tolerancing. If you have a look at some of the dimensions at the bottom here, I'll just zoom in so you can see properly. You can automatically do tolerancing by going to the auto tolerance commands over here. You can say auto tolerance with brackets. Let's take the first one. Let's say it's an H7 type fit. You say OK, purely indicate to the dimension. Caddie will do the H7 fit and correct and put in brackets for you the appropriate tolerances. You can say auto tolerances by dual. Let's use the next one as an H9 fit, the next one in the list. Purely pick at the dimension and you can see Caddie has amended the dimension for you. You can also go to just normal auto tolerances. Let's say C11. Say OK. Indicate to the dimension and Caddie will change it automatically for you. The next one we're going to have a look at is the pipe command. If you look at the pipe command, you can specify the color for the outside lines, for the center lines, the physical pipe diameter. Draw the flanges and use opaques. Remember, opaques blanks out data underneath. So you say OK. You're going to start at the point. Say go to that point over there. That asks you nominal bend radius. I'm just going to indicate freehand somewhere over here. Use the same bend radius again. Go back across over here. And if I say cancel, you can see that Caddie's drawn the pipe for you, did the flanges, did the bend radius, and it's blanked out the data underneath because we make use of opaques. When doing mechanical drawings, even something simple like a center line could become a major issue. Caddie makes life so much easier, and I'll show you why. If you pick the center line command, Caddie will ask you, show me what pen you're going to use and what line style you're going to use. I'll say OK. Now Caddie asked me, indicate the center of the line. So I'll just go to the point snap mode, which is the center at the moment over here. And what we'll do in freehand is just indicate to the outside over there and see what Caddie will do. It'll actually trim those lines, the center lines, to the same length on the outside automatically. How many times do you do that? And if you have to do that manually, it's quite a pain. You can use balloons. Balloons, pick the pen, pick the height. Caddie will ask you the starting number for the balloon, what is the header, it's an arrow, and the scale settings. So you go OK, it says where would I like the balloon, and then indicate, and you'll see it sticks a 1 in the balloon there. It says increase, yes. So now I'll just pick, and Caddie automatically increases. If you don't want it to be increased, you say no, and you pick there, and it won't increase at all. Also the same with numbers. Pick the sizes, set the scale settings, and you now physically just can go indicate the number there. Increase yes, I'll zoom up there for you because we have a smaller text and say 2A, increase yes, 3A, increase no, 3A again, increase yes, 4A. So you can see Caddie will do all of that for you automatically and help you to quickly get to your end results. We're now going to move on to something called PC diameter. And what we're going to do is pick on the command for you. Caddie will prompt you, what's the PC diameter? Let's say in this case it's 150 millimeters. We can have 4 units. You can have a start angle if you want. The nominal diameter is 10. Let's make that 12. Now let's have a look and see. Okay, those are holes and they are tapped holes. Yes, they are countersunk. So we'll say OK. Go to your snap, click on that center there, and see what Caddie automatically has done for you. Done a lot of work for you already. Done the holes, indicated correct line styles, trimmed the center lines for you automatically. Go to the same command again. That's what the magic that happens. Again, 150. Let's say now there's 6 units, and they are now bolts. We're going to change the pen color a bit. Let's say to yellow, or let's say green color again. Say OK. Go to the snap, indicate there, and see what Caddie has done for you. It's automatically, parametrically generated the bolts for you. It's spaced them at 6 equal spaces, repeated them around for you. Let's go to the next lot. Same, piece of diameter again. Now let's change some of the colors here to something else. Let's say it's a red, and that will be due as green. Now we'll say, okay, they're cap screws, or they've got a flat washer underneath, or nuts. Let's say it's a nut with a flat washer. And in this case, it's not 6 anymore. We'll have an odd number, it's 5. Say OK, go to your snap, snap there, and see the magic happens as Caddie automatically draws it. Now the task of drawing bolts and nuts made easy in Caddie. We'll have a look at the bottom over here. As you saw on piece of diameter on plan, you can draw them, but you can even draw them in section. Let's have a look. Bolt on that side, you physically fill it in. It's an M10, the length is 65, the thread length is 26. You carry on the height at 8, pick the pin, pick the line. We say OK. Caddie asks indicate position for bolt. So I use the snap, say that's the position for the bolt. Pick it over there, and it draws it right through for you. In this case, I haven't automatically drawn the nut, so I'm just going to do it manually with the nut on that side. Once again, what you would like to see, the diameter, the height, the 2 or 3 sides. Let's say it's 3 sides. Say OK. Position for the bolt, snap again. That's the center, and against that side over there. So you can see Caddie makes it so much easier to draw these things in plan or in section. It can draw the threads, bolts, the nuts on the side, even do angle lines and I-beams for you, but we'll have a look later on. Whole symbol library is captured in Caddie as well, easy to use. What we then can do as well is small little things like on this mechanical 2 side, isometric symbols. Let's have a look. An isometric symbol. Let's draw a valve, and it's a 100mm valve. I just indicate to the line, Caddie will go pick up the angle and draw it accordingly. Let's see some more symbols. Let's say now this is a non-return valve, and I zoom out and I pick on the line there, and Caddie will pick up the angle and draw the non-return valve. You can do a lot of others. You can also do things like resistors and diodes. Let's zoom up into a smaller area over here, different scale. You can do a diode. You can physically have the number. You can calculate it if you want to, the scale, and create it as a block for some intelligence. You indicate the line, indicate the direction, and it will do the diode for you. The resistor will do as well. Tolerances, the scale again. Stick it down there, and it will draw the resistor for you. We can move on to some of the commands. Can draw gears for you, developments for you. Let's have a look at just the standard development with the pipe T development. It'll ask me, will I open a new drawing? I say yes, it's fine. Let's say the pipe diameter is 75. Number of segments is 6 segments. Say OK. Pipe side view, development view over here, and Caddie will go and do the development for you. Pick that, and you can actually move that quickly as well, where you would like to have it if you want to move it around on your drawing. So you can see developments, and there's some more further detailed developments for you as well. It can do gears, it can do cutting paths, tool paths of a gear as well. The number of teeth 20, let's say piece diameter is 200, the pressure angle is 20. I'm just going to use some of the defaults over here. You say OK, and Caddie will draw the tool path for you that cuts the teeth of the gear automatically. If we move over to mechanical number 3, here's some nice developments. You can do developments of a square T-piece. You can do developments of a cone. You can do developments of a hopper. Let's have a look and see some of these ones. So let's say a cone that cuts into a pipe, intersecting pipe. Caddie will ask you, you want to open a new drawing? You say yes, I'd like to stick that down on the new drawing. Now you can see the parametrics coming into play. The sizes A, B, D, E, C. You can change them on the fly. Say it's 395. Let's say it's 382. The size there is 64. Let's make it 63. You can change the angles of 60. Let's make it 65. and by purely indicating OK, you'll see what it will do. It will do the pipe and the cone and the intersections. We'll draw a spline on the cut lines over here so that the sheet metal development can be done. So that is pipe into a cone. We can have a hopper. Let's say do a hopper. Let's start a new drawing again. Let's parametrics of the hopper 480. Let's make it 495. And I'll just change some of the values here. You can see 228 and 235. Again, you say OK. It'll draw it and it'll actually develop the hopper for you automatically over there. Let's have another one, a pipe with a gusset. Some of them can get very, very difficult if you need to draw them manually. Open a new drawing, yes. Let's put it on another drawing. 457, 260. I'm going to use the standards as is. You can change those values as you like. Say OK and see what Caddie will do for you. Does the development automatically for you. Very quick and very easy. Let's have a look at Mechanical 4. We'll have a look at welding symbols. Pick on the command. Get a very nice dialog. It'll tell you what type of sketch weld, what type of weld you can use. See the picture at the bottom here. It explains it very nicely for you. The arrow side, the other side is the edge, the corner, is the fillet, bead, surfacing, fusion spot, plug or slot or stud. And you can pick them on and off on the right hand side here as well. So we'll just use default. First of all, it says show me the position. The tail position is to the right. I'll indicate to where the arrow must head, and I just press enter, and Caddie will draw that welding symbol for you automatically. Let's just look at some of the others that you can do. Just another example or two. Pick the welding symbols again. Go through your options. Pick on the head side. Say OK. I'm just going to do it freehand over here. First of all, you pick the tail side, the direction of the arrow, and enter. And Caddie will do the weld accordingly. I'll zoom up a bit more so you can see. Let's do another one. You can go and pick them off. Have that one. Say OK. Once again, position, direction of the tail, leader arrow, press enter. And as you can see, it will automatically do the welding symbols for you. After having a look at Caddie's mechanical application, it leads into the steel application. We'll have a look at steel application 1 here. First of all, we can do some general arrangements. We can do beams. We can do bracing. First of all, you can set up all your pins, what the colors must be. You say OK over there. Then your bracing definitions. What would you like to see? Would you like to see gussets, end holes, mark numbers, balloons, details, and the text sizes as well? So let's go OK there. We'll do some beams first of all. So we'll do the beams. You can see the whole lot. Remember earlier in the mechanical side, I mentioned the profiles that we've got. Have a look and see there's all the profiles, the I sections, the H sections, angles, equal angles, structural T's, square hollow sections, circular hollow sections. The whole lot is available over here. So we can have a look there. Pick one of the ones further down the line over here. And a steel member, the origins in the center. So I'll just say OK. And I'll just pick from the bottom on the elevational section. Pick there, pick there, pick there, pick there. I'll zoom up. You see what it's automatically done on the center. Stuck it down for us over there. So we can do the bracing as well. Let's have a look and see. There's angled bracing. Now we can do angled bracing. We'd say equal angles. And we'll pick a member over here, which is 45 by 45 by 5. You'll have a look and see over here. Leg top facing, leg bottom facing, just from the side that you're looking at. There's a steel, aluminium or brass. Draw a center line. The orientation is diagonal, horizontal or vertical. It's diagonal. So we'll say OK. Now Caddie asks you, and it works on the centers automatically. That's why it goes to the intersection, geometry intersection line automatically. It says show me the diagonal intersection point. So I go from that point to that point. Caddie asks me what's the left clearance, the right clearance, the top and the bottom. Number of holes, let's say 2, and the hole diameter is 10. So we say OK. It draws it for you, wants you to put down the mark number, sticks it down there, and if I zoom up over here, you'll see what it's done already. It's done the holes, the plate to the center, and it's done the diagonal bracing for you automatically. You can do the same thing. Let's say butt bracing. Let's take another member over here. Let's say 60 by 60. It's still steel, still diagonal. Leg bottom facing. Say OK. Indicate the point, intersection, left clearance, right clearance, the top and the bottom. Hole diameter is 10. Maximum batten spacing, let's say, make it at 50, and we'll say OK. and it'll actually do that for you automatically as well. So as we go along, you'll see what it'll do. Stick it down there for you, draw the members in there for you, so you can see it'll automatically do a lot of it for you. Moving on to the steel number 2, you can draw holes individually. Let's start with a staircase in section at 45 degrees. So I'll say, well, I'll draw a staircase from this point to that point. Over there, it draws the section for you. If you zoom up again, you can see the amount of detail that you're actually going to get. Very, very nice. You can draw a simple staircase as well. Things that takes a lot of time to manually draw. You can draw a cat ladder. So say that's the top and the bottom and to the left. It'll zoom up, see what it does for you. Draws the members of the cat ladder, starts drawing the cage over there. Draws the cage right up till the end of the members over there and extends it right past. So you can see very, very quick and very easy. You can also just have railing horizontally, picking from a point to a point, and it'll actually do the railing for you horizontally as well. So as you can see, a lot of things happen automatically in a couple of clicks. I've done a general arrangement with cat ladders and staircases of steel. We also then link to design packages, something like Procon is very popular. You can do trusses. I'm just going to show you over there. A steel truss, say open that for me. You'll see the nodes over left here. You can modify and change the nodes. You can then say, okay, I'm happy with what I'm seeing here. The design was fine. Say, okay, it says show me. I'll just go back to the construction intersection over there. Stick it down there. It'll do the truss for you. It asks you start position for purlin spacing, end position, and I'm just going to enter. And it'll actually divide it up and see what it's done already. Correct dimensions for you of the truss that was designed in Procon, very easily drawn in Caddie for you. This can also happen in the 3D environment. We've got the AEC section, so that's purely arrangements and shop details in the 2D environment. I'm just going to orbit a bit over here. I've got a couple of points over here that you can see in 3D. So I'm going to just draw a couple of members in the AEC side as well that you guys can see, structural members. That it can be done in 3D as well. So we're going to do a structural member. So we'll do an H section again from points. We'll do a column, and the height of the column, let's say it's 4 meters, and the origin is in the center. So what I'll do, I'll just go and say, give me a column at points, intersection, that point, that point, that point, and that point. You can go back to structural member again. I'll zoom up a bit so you can see what it's done. See, it's done it in 3D for you. So what we'll do, we'll say another structural member. And we'll do an I section and a smaller section over here. We'll draw that as a beam. Say OK, and I'm going to draw from point to point. Spacebar, hit the same thing again. OK, I'm draw from point to point. And as you can see, you've now drawn in 3D the structural members. You can physically trim those structural members by clicking on the structural member. Selecting it on the right hand side over here. There's a lot of controls in the properties over here that you can work with the structural member, trim them, move them. If you right click on it over here, you can see the structural member. You can copy it, you can hatch, you can change the style of it, you can edit the style, you can edit the displays of it. So yes, you can draw in 2-dimensional and 3-dimensional. That brings us to the end of the mechanical and steel applications. Thank you.